yourself. Okay, so the exam has 10 questions. 8 are multiple choice, or 7 points apiece. That's where most of the points are being lost, in multiple choice, not the free response. All right? There are 2 free response. Each side is worth 22 points apiece. All right?
Why is Big Blue Button a good thing?
Oh, shoot. I have the wrong slide. So there's a good question. Less than versus less than or equal to. A normal distribution is a continuous distribution. So as far as we're concerned, those are the same. Happy birthday, Melissa. Yeah, that's in 2 days, right? Happy birthday. The D1 reflection should still be open for full credit through November. Open for late credit. I need to double check the C3 reflection. I probably need to archive the current assignments and then get that straightened out. So we're going to do some quick review. You will be getting, honestly, this is on the first page of your exam. Not that problem, but a problem like that, where you have information, all right? So you can see, you should be able to compare people using what? Z-scores. Do you actually have to calculate probabilities or percentiles?
No.
No, Z-scores are good enough, all right? So Z-scores are fine because actually, technically, well, you can only calculate probabilities if the distributions are actually normally distributed. So luckily on the test, they are approximately normal. So if you calculate probabilities, I don't have to ding you. If you calculated probabilities for something not normally distributed using a normal distribution, I would have to ding you. Do you see the difference? So don't make assumptions that you shouldn't be making. So on this one, basically all you do is you find the Z-scores, whoever's higher, that's better. Higher is better. Now, what if I was looking at their batting average and, oh, I don't know, what's another good stat for a baseball player? Huh? OPS. What's OPS? Ah, okay. So, okay. Is it weighted higher than the batting average?
Yeah, it's your on-base percentage plus your slugging, so it's 2 variables. So a lot of it's over like 1.
So how do they manage? So they probably do a Z-score for these people, right? They compare their stats, and you can compare more than one thing for 2 people, right? So you use common sense to figure out how to compare things. Hint, hint, wink, wink, nudge, nudge. And actually, most people get this problem super right. No problem. Okay, using the empirical rule to determine what percent of temperature. So this is actual data. The average human temperature is approximately normal with an average of 98.2 degrees and a standard deviation of 0.7 degrees. What would be the percent of temperatures we expect between 96.8 and 99.6? If you happen to get beautiful Z-scores like -2 and 2, and it says use the empirical rule, that answer's really quick, isn't it? -2 to 2 is what? 95%. All right. What is the probability a randomly selected person will have a body temperature less than? So the common thing I saw in your quizzes, because in the review I did a greater than, but on the quiz I did a less than and a greater than, and some of you did greater than for the less than. So if you're doing probabilities, it doesn't hurt to draw the distributions. Okay, it really doesn't. So what is the probability a randomly selected person will have a body temperature less than? If this is a free response, ideally, you would be finding a Z-score, especially if I say use Z-score. If I don't say use Z-score, I'm going to be lenient on this test, all right? Because I want to make sure I'm asking for what is scored on the AP exam. Now, they frequently want Z-scores. All right. So the table, I can use a table. I can also use a shortcut. What's the shortcut to do this one? Yes, how? How could we do this super fast? Normal CDF. What's the lower? Negative, really negative number, like -1,000 is probably far enough away. And what's your upper? 97.5. What did I put in from you? 98.2. And 0.7 for the standard deviation, and you should get an answer very close to 0.1587. You may not get 0.1857 because this one Did you guys get it? Did you do normal CDF? Okay, so are you on normal CDF?
Yes.
All right, what's your lower? Is that what you have? Okay, so you have negative 1,000. What's your upper? 97.5. What's the mean? 98.2. What's the standard deviation? 0.7 is correct. Hit enter. And you should get about 0.1587. You'll probably maybe 0.16, maybe 0.157. Somewhere around there. Okay? Is that what you got? Okay. All right. By the way, now if I said someone is 2 standard deviations below the mean, all right, is that the standard deviation? No. What is that? It's about 0.1587, kiddo. That's what you should have gotten on the calculator. Oh, so my question was, unrelated to this problem, if somebody is like 2 standard deviations below the mean, all right, is 2 the standard deviation? No, what is 2?
The number of
Standard deviations away. That's how we interpret a z-score. It's a z-score, although I left off something. What did I leave off? The z-score is actually not 2, but -2, because I said below the mean.
Oh. The z-score, so the absolute value of the z-score is the number of standard deviations
Away from the mean. If it's negative, it's below. If it's positive, it's above. Right? That's how we interpret a standard deviation or a z-score. And yes, that is on your quiz. All right. What is the probability a randomly selected person will have a body temperature between 96 and 98? Here's the math, doing it by hand. I could do 2 z-scores. I could do area to the left. It's honestly a lot faster with the calculator. I would do normal CDF because I'm going from values to percentiles. My lower is 96. The upper is 98. The mean and the standard deviation did not change. It's still 98.2 and still 0.7. Yes? All right. Feeling good? You should be able to get roughly 0.3867, maybe 0.39. Yes?
But would this be like multiple?
That's what I would do. So if you're doing Z's, if I ask for a Z, give me a Z. Otherwise, I have to dig you a tiny bit, but not completely. So if you're like, I have no idea how to calculate a Z, though most of you should, just do it on your calculator and put the answer down. You will get partial credit. It's from the table, kiddo. The table only gives you area from the left. If I'm doing technology, I don't have to do that. All right? What is Q1? You guys should have the z-score for Q1 memorized. What is it? Negative 0.67 is correct. How do you get that? You look for, that one's inverse norm when you're going to a z or a value. And the area is 0.25 to the left. Because I'm doing z-scores, I could do 0 and 1 for the mean and standard deviation, but because I know the mean and the standard deviation, I can also do the shortcut. I had just put in the mean and standard deviation. Okay? Oh, ignore my ugly drawing. What should their target deviation be if they want 95% of the boxes to weigh at least 78 ounces? All right. So on this one, we have an average, but we don't have the standard deviation. If you are missing the mean and or the standard deviation, you must use a z-score. All right. In this horrible drawing right here is what I was attempting to do with my mouse. Technically, it's a normal distribution, and I'm trying to shade in about 78. No, what percent of the area? Area to the left is 95%, right? Over here, 5% here. So I can find the z-score either by doing inverse norm with 0.05 to the left, And I have to do 0 and 1 as mean and standard deviation. Why? So I know the average is 80 ounces, but I'm trying to find the standard deviation.
1.645.
So I can't use the 80 because I can't use the shortcut because the standard deviation is what I'm trying to find. So I can do inverse norm of 2 choices, inverse norm, and my area is 0.95, then that's a 0.95, 0, 1, because that's my mean and standard deviation, and say right, on the newer calculators, which we have, or I could do 0.05 and say, or I could use table and just look up 0.05. That will give you the z-score, and then you use the algebra and the formula to solve for the value of standard deviation. All right? Okay.
Why would you put in standard deviation as 1 on inverse norm?
Great question. For the standardized curve, what is the mean?
Oh, because you're finding z-score with that, not the section.
Correct. I'm finding a z-score. So the mean is 0 for a standardized curve, and the standard deviation is 1 for a standardized curve. Do you think we'll ever do a problem where the standard deviation is 0? No, why not? It's just one value. There's no spread. Unlikely on your exam. Okay, what does it mean if 30% of the values are above 70? Again, because you're finding mean, you must work with standardized values. So I'm doing inverse norm. I can either do inverse norm at 30% with 0 and 1 and say right, or I can do inverse norm with 0.70, 70% and 0 and 1 and say left. I get my z-score, which is 0.52. Does that make sense that it's positive and above average? It's above the middle percent, right? It's at 70% from the bottom. The percentile is 70th percentile, so it's definitely above the median. And for a normal distribution, that would mean it's also above the average. All right, so just solve. The mean is 62.2. Would a temperature of 100 degrees Fahrenheit be considered an outlier? Yes, you are still expected to calculate if things are outliers. All right. You got Q1 is negative 0.67. Q3 is positive 0.67. I go find my value for Q1 by substituting negative 0.67. I know my mean and I know my standard deviation, so I can find the value. Now, I can also do this using the shortcut, inverse norm, and say 25%, 0.25, because it's a 25th percentile, and then put in the actual mean and standard deviation, and it will just spit out the value. All right? And then Q3 isn't there. You still have to find the IQR. And then this one's 100 degrees is above average, so am I concerned about low outliers? No, hopefully not. Okay. And I just check, and it is just below the cutoff, so it's not an outlier. And then one more just to show you before we get started. The heights of young women can be modeled by a normal distribution with a mean of 64 and a standard deviation of 2.7 inches. This one is continuous because we're assuming people don't make little jumps, all right? And when we interpret the standard deviation, remember how to interpret standard deviation. The heights typically vary by 2.7 inches, the standard deviation, from the mean, which is 64 inches. All right? If you want to find the probability that y is less than 63, you can find a z-score. All of these I do z-scores, but you can also do the shortcut, right? And then I get my area, and you can see here if I'm using Statlet, I can use the normal model with 64 and 2.7, and area to the left is 63. All right. Let's go ahead and make sure that you put up your phones.